sub d equaling 0. That's the only thing in our entire equation which can equal 0. We've proven that every single factor cannot be equal to 0 because they're distinct numbers, and so we're left with a sub d being equal to 0. What does this mean? Well, a sub d is a coefficient. If a sub d is 0, what does that mean about everything else in our entire function? If a sub d is equal to 0, then it doesn't matter what x minus r sub d or x minus r sub d minus 1 is. My entire polynomial would just be equivalent to, and I'm going to write it here, it would be equivalent to 0. Is that possible? That would mean the degree of our polynomial is also 0. But if you think back to the very beginning of our proof, we assumed, right, that we were working with a polynomial of degree d greater than 0. So what we see is that if we end up with d plus 1 roots, what we end up with is that our entire function must be equal to 0. Our entire polynomial would be reduced to 0, and that's a contradiction. Another way to write it, another symbol for contradiction is this. We simply cannot have a sub d equal to 0. And so we've run into a problem. We finally found the problem that we were looking for. So since a sub d cannot be equal to 0, we cannot have d plus 1 roots. What is the maximum number we can have? The maximum number of distinct roots is d. I'm going to squeeze that in at the bottom. Is d. And so there we are. We're completely done. We've shown, look, if we have d roots, we're fine, right? When we finished with d roots, and I'll make sure that we cross this out. This was just to show what would happen. If we have d roots, then we end up with d factors. That makes sense. We're used to that. That's what we would expect, because in order to have a d-degree polynomial, you'll need d factors. But once we introduce the part where we have this last root, r sub d plus 1, all of a sudden, we are forced into the situation where our coefficient, our leading coefficient, is 0, which makes our entire function 0. We discussed this at the beginning as well. A sub d, if it's the leading coefficient for our d term, x to the dth power, it can't be 0 because we realized that would make our premise of it being a d-degree polynomial incorrect.